G'day viewers. In this segment we'll use a program called Traceroute that you can run on hosts at the edge of the network to peek into the network and find out a little bit about its structure. Okay, so here's the context. We've talked before about the Network Service API, going through sockets in particular. This API lets apps talk to other apps virtually by making local calls, and it's as though they're talking across the network here, but they have no real idea what's inside the cloud of the network. It's a mystery. Now this is actually a very good thing. Your application structure shouldn't depend at all on the network path, whether it's a short one, whether it's a long one, whether it goes through Boston or not. It should be irrelevant to the structure of applications. Otherwise we'd have to write an awful lot of applications. But you might be curious to learn what's inside the network. You might want to know which path your packets take. Do they go in a direct route, a roundabout route? Do they go through a lot of routers or a few routers, and so forth? Fortunately, there's a program called Traceroute that we can run to look inside the network as we send packets from a particular source to a particular destination. Traceroute is the name of this widely used command line tool to let hosts peek inside the network. It was developed by a guy called Van Jacobson in '87, it says here, I believe that. Traceroute is widely available on all different operating systems. Its name varies a little bit. On Windows, it's called Traceroute. And the way it works is it uses the network-to-network interface, actually the IP protocol, which we will study later in this course, to probe the path inside the network. We'll explain much later what's actually going on at a detailed level, because we won't really be able to appreciate it until then. For now, just take this as a quick way to have a look inside the network for fun to see what's in there. Here's how Traceroute works. It probes the network path from a given host towards a specific destination. Let's just say we're going to send traffic to www.uw.edu. And Traceroute then probes successive hops along the path. It does this by sending out a message, first of all, a single hop, and towards the destination, but it asks it only to go a single hop, and then return a message to the host. Then it sends out a message 2 hops and asks that router to return a message to the host. Then 3 hops, return a message to the host, and so on. And eventually, you can see, we will, in the very next go, reach the host, and we'll get a message back from the host, and that way we'll know we're done with this process. These messages, which are being returned from the individual routers, allow us to identify the routers that are inside the network, as well as gather some information such as roughly how far away they are in terms of time and distance, and also make educated guesses about where they physically lie or where their location is along the path. Here's the same version, just cleaned up a little bit. So you can see the messages that are going out and the information that's been returned from the path. Normally we wouldn't see anything that's in the middle. You would simply send a packet here from the local host, and it would go all the way to the remote host without a clue of what's inside. Well, let's see an example of Traceroute in action. I'm actually in Barcelona right now, so let's try and find out what path is used in the network as I send packets from here to the web server at the University of Washington. I'm on a Windows system, and this window here is my command line, my command prompt. Let's enter a command in. We'll enter a traceroute. Traceroute to www.uw.edu and see what happens. I'll hit return, and Traceroute is away. What it's doing is it's sending its packets to probe successive hops. You can see the very leftmost number is the hop number. It actually sends out 3 entries for every hop. And the first numbers are the timing. So you can see initially it was very fast, within a millisecond within my house. But as we got further away from my house and further out into the network, the times got larger, up to a couple of 100 milliseconds. Now on the right-hand side, you can see the names or identifications of all of the routers. Both the IP addresses are given, as well as some of the names there. And we can take some hints from the names and work out somewhat about where the packet is going. Some of those names have Telefonica in it, so it looks like it goes through the Telefonica network. And it looks like it goes through the level 3 network. You can see San Jose there, as well as Seattle later on, and eventually it arrives in some computers at Washington. On hop number 17, we see stars back. The network actually wouldn't return any information for what was at hop 17. Something must have been there, but whatever it wasn't telling us, because it's not required to implement Traceroute. And there you have it. We've run Traceroute and we've got back a fair amount of information about the path through the network from Barcelona to UW over 19 different hops in the network. And now we can take the same information that was provided by running the Traceroute program and use it to draw a diagram of the network. So here's my interpretation of some of that information. We have my computer, my host, on the left, and the server that I used as a target for Traceroute on the right. That was www.uw.edu. In the trace, you'll actually see it also has an alternate name, www.1.cac.washington.edu. As we went along the path, I've divided it into several rough segments. First of all, there was about one hop within my home, I'm guessing. Then there were 3 hops through some network called TDE. I don't know what that is for sure, although I'm pretty sure it is some kind of Telefonica access network. And by the time we got to the other side of the Telefonica access network, you could see here the latency, the round trip latency, the time delay was up to about 100 milliseconds. So that network took us a little bit further away. Then we had 4 hops through some network whose name looked like a Telefonica network. That took us further away. We're now 180 milliseconds. From the names, it looked like we entered the Telefonica access, or somewhere inside that network. We passed through New York City and we went to San Jose. At San Jose, we then transferred to a different network, the level 3 network, went for 6 hops through it, and then we arrived in Seattle, went through something called the PNW Gigapop. You wouldn't know what that is for sure. Actually, one thing you can do is you can Google all of these names to see what comes up. That's actually the Pacific Northwest Gigapop, which is a location in the Pacific Northwest for other networks to come together and connect. From that network, we go into the UW network, and then there are 3 hops through routers until we reach the server at the very end. That's what Traceroute shows. Quite a lot about the network in between, and we're done.